Hello, in this lecture I will answer two questions. The first question, we will find out the size of this angle ABC is equals to x. We have to find out the value of angle x. And in the second question, we will find out the length of line segment AD. This is also equals to x. So we have to find out the length of line segment x. So we start with the first question. In the drawing, we have quadrilateral ABCD. We know that BC equals to BA equals to AD. Those two angles are both equal to 80 degrees. Again, our task is to find out the size of this angle ABC is equals to x. We have to find out the value of angle x. So first of all, we will join points B and D together by a straight line. By joining points B and D, we can get here triangle ABD. And in triangle ABD, side AD equals to side BA. And we have the rule that in front of equal sides in the triangle there are equal angles. Again, in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other in their sizes. So we define the size of this angle as alpha. Then the size of this angle must be also equal to alpha because they are equal to each other according to the ordered dimensions. We also know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle ABD, alpha plus alpha, that is 2 alpha plus 80 degrees. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. So, already known, in line ABD, the sum of those two angles must be equal to 180 degrees. That is to say, 2 alpha plus 80 degrees in total must be equal to 180 degrees. And again, in triangle ABD, the sum of the angles must be equal to 180 degrees. That is to say, 2 alpha plus 80 degrees equals to 180 degrees. Here, we will subtract 80 degrees from this equation, and we get that 2 alpha equals to 180 degrees. 80 degrees is 100 degrees. So 2 alpha equals to 100 degrees. Here we divide this equation by 2. And finally get that alpha equals to 100 degrees over 2 is 50 degrees. So see, those two angles are both equal to alpha, and therefore each of them equals to 50 degrees in size. What is the size of this angle BDC? From the drawing, it is very easy to see that angle BDC equals to 80 degrees minus 50 degrees, that is 30 degrees. So angle BDC equals to 30 degrees in size. The next step, we will define this angle BCD as beta. And we will focus on this triangle ABD. So we will actually implement the law of sines in this triangle ABD. So a bit quicker on the law of sines. The law of sines is true in any triangle. This is a triangle ABC that could be any triangle. The length of side AB is C units, side AC equals to B units in its length, side BC equals to A units in its length. This triangle ABC that could be any triangle, according to the law of sines, the following equation is true. A over sinus A, again, capital A, capital B, and capital C are the angles of inside this triangle ABC. Capital A, this is angle capital A. So angle BAC equals to capital A. This is angle ABC, that equals to capital B, degrees in its size. This is angle ACB, that equals to capital C in its size, according capital C degrees in its size, according to our definition. Okay. So maybe I write it down here. The size of this angle is capital A. The size of this angle is capital C degrees. And the size of this angle ABC is equal to capital B degrees in its size. So in this triangle ABC that could be any triangle, according to the law of sines, the following equation is true. A or sinus A equals to B or sinus B equals to C or sinus C. Again, this triangle ABC that could be any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. So we can actually implement the law of sines in our drawing in triangle ABD. So according to the law of sines, in triangle ABD, the following equation is true. BD over sinus 80 degrees equals to AB over sinus 50 degrees. And again, BD over sinus 80 degrees equals to AB over sinus 50 degrees. So I write it down. In triangle ABD, according to the law of sines, the following equation is true. BD over sinus 80 degrees equals to BA over sinus 50 degrees. And again, in this triangle ABD, according to the law of sines, the following equation is true. BD over sinus 80 degrees equals to BA over sinus 50 degrees. It's given us the question that BC equals to BA equals to AD. So we define side AD as A, and therefore side BA must be also equal to A, and side BC must be also equal to A when it's in itself, because of the fact that all those three sides are equal to each other on their lengths. So if you found out that according to the law of sines, BD over sinus 80 degrees equals to BA over sinus 50 degrees. Here we will substitute 80 degrees by 2 times 40 degrees, and we will substitute 50 degrees by 90 degrees minus 40 degrees. Repeat again, we substitute 80 degrees by 2 times 40 degrees here, and we substitute 50 degrees by 90 degrees minus 40 degrees. And we get that BA is A, or sinus 80 degrees. Again, we substitute 80 degrees by 2 times 40 degrees. So it is sinus 2 times 40 degrees and is equals to again here we have BD, so we don't know the length of side BD, so we leave it as it is. It is actually BD or sinus 80 degrees. And sinus 80 degrees equals to sinus 2 times 40 degrees. And it is equals to BA or sinus 50 degrees. BA equals to A, so we will substitute BA by A or sinus 50 degrees. Again, 50 degrees is 90 degrees minus 40 degrees. So if you found out that BD over sinus 2 times 40 degrees equals to A over sinus 90 degrees minus 40 degrees. We use here two trigonometric identities. The first trigonometric identity is as follows. Sinus 2 alpha equals to 2 times sinus alpha cosine alpha. And we will use another trigonometric identity in our equation. This is actually sinus 90 degrees minus alpha equals to cosine alpha. So we use those two trigonometric identities in our equation. And we get that BD or sinus 2 times 40 degrees. According to this trigonometric identity, sinus alpha equals to 2 times sinus alpha cosine alpha. We will get that sinus 2 times 40 degrees equals to 2 times sinus 40 degrees times cosine 40 degrees. And it is equals to A over sinus 90 degrees minus 40 degrees. According to the second trigonometric identity, that is to say sinus 90 degrees minus alpha equals to cosine alpha, we will get that sinus 90 degrees minus 40 degrees equals to cosine 40 degrees. So in total, if we found out that BD over 2 times sinus 40 degrees times cosine 40 degrees equals to A over cosine 40 degrees. Here we have cosine 40 degrees on both sides of this equation, so cosine 40 degrees will get cancelled. After we cancel cosine 40 degrees from both sides of the equation, this side of the equation we left only with A equals to, and on the other side of the equation we left only with BD over 2 times sinus 40 degrees. So to that, if we found out that BD over 2 times sinus 40 degrees equals to A. Here we will multiply this equation by 2 times sinus 40 degrees. And we get that the missing side BD, this is the missing side BD, is equal to 2A times sinus 40 degrees. Repeat again, if you found out that this is the missing side BD, This equals to 2a times sinus 40 degrees. So I write it down. Let me see side BD. The red line equals to 2a times sinus 40 degrees in its length. In the next step, we implement the law of sines. This triangle BCD. Repeat again. We will implement the law of sines in this green triangle BCD. According to the laws of sines, this green triangle BDC, BD over sinus beta equals to BC over sinus 40 degrees. Repeat again, in this green triangle BCD, according to the law of sines, the following equation is true. BD over sinus beta equals to BC over sinus 40 degrees. We already found out that BD equals to 2a times sinus 40 degrees. Therefore, we solve the BD in the equation by 2 times a sinus 40 degrees over sinus beta. And it equals to BC, BC equals to A, according to our definition, or sinus 30 degrees. Sinus 30 degrees is 1/2. So, in this side of the equation we have A over 1/2, A over 1/2 is 2A. So in total, we found out that two A times sinus 40 degrees over sinus beta equals to 2A. Here we have 2A on both sides of this equation, so 2A will get cancelled. Once I cancel 2A, this side of the equation we left only with sinus 40 degrees over sinus beta equals to 1. 2A over 2A is 1. Here we multiply this equation by sinus beta. So you get that sinus beta equals to sinus 40 degrees. If sinus beta equals to sinus 40 degrees, it means that beta equals to 40 degrees in its size. But we have another solution for beta. According to the following trigonometric identity, sinus alpha equals to sinus 180 degrees minus alpha. And again, here's the trigonometric identity that says that sinus alpha equals to sinus 180 degrees minus alpha. So according for this trigonometric identity, we will get that sinus 40 degrees equals to sinus 180 degrees minus 40 degrees. And 180 degrees minus 40, 180 degrees, of course, minus 40 degrees. And 180 degrees minus 40 degrees is 140 degrees. So from this equation, we will conclude that sinus 40 degrees equals to sinus 140 degrees. Sinus 40 degrees equals to sinus 140 degrees. So we have this equation. According to this equation, sinus beta equals to sinus 40 degrees. But we just right now found out that sinus beta equals to sinus 140 degrees. So we add here to this equation that sinus 40 degrees equals to sinus 140 degrees. Those two sides of this equation are equal to each other. That is to say, sinus beta equals to sinus 140 degrees. So if you found out that sinus beta equals to sinus 140 degrees, if sinus beta equals to sinus 140 degrees, it means that beta equals to 140 degrees in its size. So the second solution for beta is beta equals to 140 degrees in its size. Well, according to the first solution for beta, beta equals to 40 degrees in its size. But if you focus on the line here, it is very easy to see that this is angle beta, that is definitely greater than 90 degrees. If beta is greater than 90 degrees, it means that beta can never be equal to 40 degrees, it is less than 90 degrees. So we can have the first solution for beta, and we take into account only the second solution for beta. It's actually beta equals to 140 degrees in its size. This is angle beta, is equals to 140 degrees in its size. In the green triangle BCD, the sum of the angles must be equal to 180 degrees according to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have in the green triangle BCD? We have 30 degrees plus 140 degrees plus this missing angle is actually angle DBC, so that the sum of those three angles must be equal to 180 degrees. So if you found out that 30 degrees plus 140 degrees plus the first missing angle DBC, so that must be equal to 180 degrees according to the rule I mentioned. 30 degrees plus 140 degrees is 170 degrees, plus the third missing angle, that is DBC. So that the sum of those three angles must equal to 180 degrees. So here we subtract 170 degrees from the equation. We get that the missing angle DBC equal to 180 degrees plus 170 degrees is 10 degrees. So the missing angle DBC equals to 10 degrees inside. This is the missing angle DBC, it is equal to 10 degrees in size. Our task is to find out the size of this big angle, angle ABC. From the drawing, it is very easy to see that angle ABC is equal to x, is equal to 50 degrees plus 10 degrees, that is 60 degrees. So, angle ABC is equals to x equals to 50 degrees plus 10 degrees, that is 60, so 30 degrees equals to 60 degrees. So if you know that this is the missing angle ABC, is equal to x, and it is equal to 60 degrees in size. So x equals to 60 degrees in size. So finishing with the first question, the next step I'll present you the second question, and we will solve the second question by using two different methods. In this second question, our task is to find out the length of this side AD is equal to x units in its length. So we have to find out the length of x is equal to AD. So we have to find out the length of line segment x. So in the drawing, we have quadrilateral ABCD. We know that those two angles are both right angles. Side AB equals to side BP. Those two sides are equal to each other. In addition, we know that the short line segment DP equals to 1 unit in itself. Line segment PC equals to 4 units in its length. Again, our task is to find out the length of this side AD is equals to x. We have to find out the value of x. So first of all, we will join points B and D together by straight line. By joining points B and D, we divided this quadrangle ABCD into two parts. The first part is the right triangle ABD, and the second part is the lower right triangle, triangle BDC. So in the next step, we will implement the Pythagoras theorem on both those two right triangles. And according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So first of all, we will implement the Pythagoras theorem on this upper right triangle, triangle ABD. Here by PT is abbreviation for Pythagoras theorem. This triangle, triangle ABD, according to the Pythagoras theorem, BD square, that is the square of the hypotenuse, equals to AB square plus AD square. And again, in the upper right triangle, triangle ABD, according to the Pythagoras theorem, BD square, that is the square of the hypotenuse, equals to AB square plus AD square. BD is the missing hypotenuse, so we leave it as it is, so it is BD square equals to AB square. AB square, but again that according to what is given as an equation, AB equals to BD. So equals to AB square plus AD square. AD is the last segment that we are looking for in this question. AD equals to x, so AD square is x square. So total according to equation 1, we actually found out that BD square equals to AB square plus x square. Likewise, we will implement the Pythagoras theorem on this lower right triangle, triangle BDC. This right lower triangle, triangle BDC, according to the Pythagoras theorem, BD square, that is the square of the hypotenuse, equals to BC square plus DC square. And again, according to the Pythagoras theorem, this right lower triangle, triangle BDC, BD square, that is the square of the hypotenuse, equals to BC square plus DC square. Again, BD is the missing hypotenuse, so we leave it as it is BD square equals to BC square. BC is also the missing side, so we leave it as it is, plus DC square. DC in total equals to 1 plus 4, that is 5, therefore DC square equals to 5 squared, that is 25. So in total, according to equation 2, we have found out that BD square equals to BC square plus 25. So actually, we have two different equations for BD square. And therefore, we will create the equation 3 that says that BD square according to equation 1 must be equal to BD square according to equation 2. So according to equation 3, BD square according to equation 1 must be equal to BD square according to equation 2. BD square according to equation 1 equals to AB square plus X square. And it must be equal to BD square according to equation 2. BD square according to equation 2, this is equation 2, equals to BC square plus 25. So in total, according to equation 3, we found out that AB square plus X square equals to BC square plus 25. In the next step, we implement the product theorem of this small right triangle times PBC. And again, we will implement the product theorem on this small green right triangle times BPC. According to the product theorem, in this small right triangle BPC, BP squared, that is the square of the hypotenuse, equals to BC squared plus PC squared. And again, according to the product theorem, in this green right triangle BPC, BP square, that is the square of the hypotenuse, equals to BC square plus PC square. This is equation 4. So according to equation 4, BP square equals to BC square plus PC square. But it is given as a question that AB equals to BP. Again, AB equals to BP according to what is given as the question. So we substitute BP in this equation 4 by AB square. So according to equation 4, we found out that AB square equals to BC square plus PC square. Because we know that BP equals to AB. So we substitute BP by AB in this equation 4. So again, according to equation 4, we found out that AB square equals to BC square plus PC square. This is according to equation 4. Well, according to equation 3, we only found out that AB square equals to AB square plus X square equals to BC square plus 25. According to equation 3, AB square plus X square equals to BC square plus 25. And because of the fact that we only found out that AB square equals to BC square plus PC square, we will substitute AB square in this equation 3 by BC square plus PC square. We'll do it now, we'll get that again. AB square is BC square plus PC square according to equation 4. So we substitute AB square by BC square plus PC square. And we have here equation 3 plus X square equals to BC square plus 25. So here we have BC square both sides of this equation, so BC square will get cancelled. So we cancel BC square. This side of the equation we left only with BC square plus x square. PC equals to 4, therefore PC square equals to 4 squared, that is 16. So this side of the equation 5 we have PC squared, that is 16, plus x squared, while on the other side of the equation we left only with 25. So total we found out that 16 plus x squared equals to 25. Here we will subtract 16 from this equation 3. We get that x squared equals to 25 from 16 is 9, so x squared equals to 9. Here we take out all of this equation and find that x equals to the square root of 9, that is 3. So if you found out that this is line 7 AD, equals to x, and x equals to 3. So the answer for this question is that the length of 9 7 AD equals to x, it equals to 3 units. Again, 9 7 AD equals to x equals to 3 units in its length. So we finish with the first method. The next step I present to you how to find out the graph of this 9 7 AD equals to x according to the second method. In the second method, we will do a construction, that is to say, we will extend side DC of this quadrilateral ABCD by 4 units. I repeat again, we will extend side DC, this side DC of quadrilateral ABCD by 4 units. We will define the edge of this extended segment. This point is point Q. DC is one side of quadrilateral ABCD, and therefore it is absolutely a straight line. DC is a straight line. When you extend the straight line by straight line, the result DQ is also a straight line. DQ is a straight line, so if you focus on the upper side of the straight line, DQ is this point, point C. Here the sum of the rest must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the rest on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of this straight line DQ at point C? We have this angle that is the right angle, plus this missing angle. In total the sum of those angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, we will join points B and Q by a straight line. By joining points B and Q, because this right triangle BCQ. In the next step, we will prove that those two right triangles can go into each other according to side angle side rule. So we have to prove that this is the right triangle PBC. So this right triangle PBC can point to this right triangle BCQ according to side angle side rule. So why those two right triangles can go into each other? First of all, PC equals to CQ. CQ equals to 4 according to our construction. We extended DC by 4 units. So that's it. CQ equals to 4. So those two sides are both equal to 4, therefore they are equal to each other. PC equals to CQ equals to 4. Or side PC of this right triangle PBC equals to side CQ, this right triangle BCQ. PC equals to CQ, they are both equal to 4, and therefore they are equal to each other. In addition, those two angles are both right angles, and therefore they are equal to each other. So actually, this is again PCP, BCP, or PCB. In the right triangle, PBC equals to this angle, this angle BCQ. In this right triangle, BCQ. Okay, again, we found out that angle PCB in the right triangle PBC equals to angle BCQ in the right triangle BQC. They are both equal to 90 degrees, and therefore they are equal to each other. And finally, this is side BC. This is the common side that belongs to both triangles. So we can write down that BC equals to itself is the common side that belongs to both triangles. BC equals to itself is the common side. So if we prove that the right triangle PBC congruent, this is the side of congruent, to the right triangle BCQ, according to angle side rule. That is to say, we should prove that those two sides and the angle that is included between those two sides, this right triangle PBC, of course, will equal to those two sides, and the angle that is included between those two sides in this right triangle BCQ. Therefore, we should prove that those two right triangles can go into each other according to side rule. Again, we have those two sides, and the angle that is included between those two sides in this triangle BCP was equal to those two sides, and the angle that is included between those two sides in this right triangle BCQ. And therefore, those two right triangles can go into each other according to side rule. And from the fact that those two right triangles can go into each other, we will derive that the hypotenuse of those two right triangles must be also equal to each other and their lengths. That is to say, PB equals to BQ. And again, from the fact that those two right triangles can go into each other, we derive that PB equals to BQ. Why PB is equal to BQ? PB equals to BQ according to the rule that says that corresponding sides in congruent triangles are equal to each other. Those two right triangles can go into each other, and therefore their corresponding sides, that is to say PB and BQ, must be also equal to each other in their lengths. Okay, PB equals to BQ. But according to what is given as the equation, AB equals to BP. Therefore, all those three sides, AB, BP, and BQ, are equal to each other. Okay, now if we found that AB equals to BP, according to what is given as the question, and because of the fact that BQ equals to BP, it means that BQ equals to BP and also to AB. And again, if we found out that all those three sides AB equals to BP equals to BQ. In the next step, we will do a construction. That is to say, we will draw a circle around point B in such a way that point B will be the center of the circle and BA will be the radius of the circle. And again, we will draw a circle around point B in such a way that point B will be the center of the circle and BA will be the radius of the circle. So AB is the radius of the circle, so we define the radius of AB as R. But because of the fact that AB equals to BP equals to BQ, all those three line segments will be the radii of the circle. Why? Because they are equal to each other. So PB is also the radius of the circle. Equals to R. Likewise, BQ is also the radius of the circle, that equals to R. It is given as a question that DA is perpendicular to AB. According to what is given as a question, DA is perpendicular to AB. Equals to perpendicular to AD. Again, this is the sign of perpendicular. DA is perpendicular to AB. DA is perpendicular to AB according to what is given as the question. And because of the fact that AB is the radius of this circle, AB is the radius. So DA is perpendicular to the radius AB. Actually, the circle is not correct. Like that. This is the circle. Okay, again, DA is perpendicular to AB according to what is given as the question, but DA is the AB is the radius of this circle. DA is perpendicular to AB according to what is given as in the question, and AB is the radius of the circle. Therefore, DA is perpendicular to the radius AB. DA is perpendicular to the radius AB of this red circle. Therefore, DA must be a tangent. DA is a tangent to this circle is point A. So now that DA is a tangent to the circle is point A. This is tangent DA, it's tangent to this circle, it's point A. So from this common external point D, we have tangent DA, that is tangent to this circle at point A. Likewise, from the same common external point D, we have secant dq. Secant dq cuts the circle to points P and Q. dp is the external part of secant dq. Again, dp is the external part of secant dq. And the secant in total equals to dq units in its length. dp is the external part of secant dq. So actually all the requirements of tangent secant theorem are satisfied, and therefore we can implement tangent secant theorem at this common example point D. Repeating again on tangent secant theorem. According to tangent secant theorem, if a tangent and the secant are drawn to a circle from the same external point, this is the common external point P. From the common external point P, we have tangent P8 that is tangent to this circle point A. Likewise, from the same common external point P, we have secant PC that cuts this circle at 2 points, B and C. So according to tangent secant theorem, the square of the tangent's length equals to the product of the secant all length and its external part. Essentially, tangent square equals to the external secant part times all secant length. The length of the tangent square is PA squared, and this equals to PB times PC. Again, PA squared equals to PB times PC. Actually, PB is the external part of secant PC, and the length of the secant in total is PC. So the product of the external part with the all part, all length of this secant that is PC, actually it is PC times PB equals to PA squared, or PA squared equals to PB times PC. Okay, so we can actually implement the tangent secant theorem in our drawing. Why? If you focus on this common example point D, from the common example point D, we have tangent dA that is tangent to this circle as point A. Likewise, we have secant dq. The length of the secant in total is dq. The external part of secant dq is dp. So all the requirements of full tangent secant theorem are satisfied, and therefore we can implement the tangent secant theorem. According to tangent secant theorem, dA squared, that is the length of the tangent squared, equals to dp times dq. Again, dA squared equals to dp times dq. So write it down. According to tangent secant theorem, if we focus on the common example point D, the following equation is true. dA squared, that is the length of the tangent squared, equals to the product of the external part of the secant, that is dp, times the length of the secant in total, that is dq. So it is dp times dq. dA equals to x units in its length, that is the last element that we are looking for in this question. So dA squared equals to x squared, and is equals to dp. dp equals to 1 times dq. dq equals in total to 1 plus 4 plus 4, that is 9. Again, dq in total equals to 1 plus 4 plus 4, that is 9. So in total we should find out that x squared equals to 1 times 9, that is 9. X squared equals to 9. Here we take a root out of this equation and find out that x equals to the square root of 9, that is 3. So we should find out that the length of line segment AD is equals to x is equal to 3 units. And again, we should find out that the length of this line segment AD is equals to x is equal to 3 units. So in both methods, we arrive to the same result. So in the next step, of the lecture, we'll start repeat on the solution of the first question, and then we repeat on the solution of the second question on both methods. So we start with the repetition of the first question. Repeat on the solution of the first question, and then on the solution of the second question on both methods. Our task in the first question was to find out the size of this angle ABC is equal to x. Again, we have to find out the size of this angle ABC is equal to x degrees. We have to find out the size of angle x. So in the moment we have quadrilateral ABCD. We know that AB equals to BC equals to AD. Those two angles are both equal to 80 degrees in their sizes. Again, our task is to find out the size of angle ABC is equals to x degrees. So first of all, we did a construction. That is to say, we join points B and D together by a straight line. By joining points B and D, we divided this quadrilateral into those two triangles. The green triangle BCD and the lower triangle BAD. So we focus on this lower triangle BAD. We know that in front of equal sides in the triangle there are equal angles. Again, in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other and their sizes. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha because they are equal to each other according to the rule that I mentioned. The sum of the angles in any triangle is equal to 180 degrees. So alpha plus alpha is 2 alpha plus 80 degrees, in total it's equal to 180 degrees. In the right triangle ABD, the sum of the angles must be equal to 180 degrees. That is to say 2 alpha plus 80 degrees equals to 180 degrees. Here we subtracted 80 degrees from this equation and found out that 2 alpha equals to 180 degrees minus 80 degrees is 100 degrees. So 2 alpha equals to 100 degrees. Here we divided this equation by 2 and found out that the missing angle alpha equals to 100 degrees over 2 is 50 degrees. So those two angles are both equal to alpha according to our definition, and therefore each of them equals to 50 degrees in size. The size of this angle BDC, from the moment is very easy to see that the size of this angle BDC equals to 80 degrees minus 50 degrees. Again, equals to 80 degrees minus 50 degrees. 80 degrees minus 50 degrees is 30 degrees. So the size of this angle BDC equals to 30 degrees. The next step we define this angle ACD is beta, and then we implemented the law of sines. This triangle ABD. So I can quickly on the law of sines. According to the law of sines, this is triangle ABC that could be any triangle. This is angle BAC equals to capital A degrees in its size. This is angle ABC equals to capital B degrees in its size. And this is angle ACB equals to capital C degrees in its size. Note that the length of side AB is C, side AC equals to B units in itself, and side BC equals to A units in itself. This triangle ABC that could be any triangle according to the law of sines is following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C. Again, A over sinus A equals to B over sinus B equals to C over sinus C. We can actually implement the law of sines in our triangle ABD because of the fact that the law of sines is true in any triangle. So this triangle ABD, according to the law of sines, we get that BD over sinus 30 degrees equals to BA over sinus 50 degrees. And again, this triangle ABD, according to the law of sines, BD over sinus 30 degrees equals to BA over sinus 50 degrees. So, first of all, we define side BC as A, and because of the fact that BC equals to BA equals to AD, and the length of side BC is A, the length of side BA and AB must be also equal to A, because they are equal to each other. And in the next step, we substitute 80 degrees by 2 times 40 degrees, and we substitute 50 degrees. We substitute 50 degrees by 90 degrees minus 40 degrees. So in total, we found out that BD over sinus 80 degrees and 80 degrees is 2 times 40 degrees. So BD over sinus 2 times 40 degrees equals to BA equals to A according to our definition. So BA is A over sinus 50 degrees. And 50 degrees, 90 degrees minus 40 degrees, so it is sinus 90 degrees minus 40 degrees. So in total, we found out that BD over sinus 2 times 40 degrees equals to A over sinus 90 degrees minus 40 degrees. Here we used two trigonometric identities in our equation. The first trigonometric identity is as follows: sinus 2 alpha equals to 2 times sinus alpha cosine alpha. The second trigonometric identity is sinus 90 degrees minus alpha equals to cosine alpha. So we have here BD over sinus 2 times 40 degrees. And according to this trigonometric identity, sinus 2 times 40 degrees equals to 2 times 40 degrees times cosine 40 degrees. And is equals to A of sinus 90 degrees minus 40 degrees. According to this trigonometric identity, we will get that sinus 90 degrees minus 40 degrees equals to cosine 40 degrees. So in total, we found out that BD over 2 times sinus 40 degrees cosine 40 degrees equals to A over cosine 40 degrees. Here we have cosine 40 degrees on both sides of this equation, so cosine 40 degrees will get cancelled. So we cancel cosine 40 degrees. On this side of the equation, we left only with A, while on the other side of the equation, we left only with BD over 2 times sinus 40 degrees. So in total, we found out that BD over 2 times sinus 40 degrees equals to A. Here we multiply this equation by 2 times sinus 40 degrees. And finally, we found out actually that BD equals to 2 times A times 40 degrees. Again, BD equals to 2 times A times sinus 40 degrees. In the next step, we implemented the law of sines in this green triangle, triangle BCD. According to the law of sines, in this green triangle, triangle BCD, BD or sinus beta equals to BC or sinus 30 degrees. Again, according to the law of sines, in this green triangle BCD, BD over sinus beta equals to BC over sinus 30 degrees. Okay, again, the green triangle BCD, according to the law of sines, BD over sinus beta equals to BC over sinus 30 degrees. We already found out that BD equals to 2 times A times sinus 40 degrees. So we solve the BD by 2 times A times sinus 40 degrees over sinus beta, and it equals to BC over sinus 30 degrees. Sinus 30 degrees is 1 half, so we solve the sinus 40 degrees by 1 half. A over 1 half is 2A. Again, A over 1 half is 2A. So to that, we found out that 2A times sinus 40 degrees over sinus beta equals to 2A. And again, we found out that 2A times sinus 40 degrees over sinus beta equals to 2A. So here we have 2A on both sides of this equation, so 2A will get cancelled. So after we cancel 2A, this side of the equation we left only with 1 equals to sinus 40 degrees over sinus beta. Again, after we cancel 2A, this side of the equation we left only with 2A, while on the other side of the equation we left only with sinus beta, sinus 80 degrees, sinus 40 degrees over sinus beta. So to that, we found out that sinus 40 degrees over sinus beta equals to 1. Here we multiply this equation by sinus beta and finally found out that sinus beta equals to sinus 40 degrees. Sinus beta equals to sinus 40 degrees. If sinus beta equals to sinus 40 degrees, it means that the beta equals to 40 degrees in size. This is the first solution for beta, but we have another solution according to the following trigonometric identity. Sinus alpha equals to sinus 180, sinus alpha equals to sinus 180 degrees minus alpha. So according to this trigonometric identity, sinus 40 degrees equals to sinus 180 degrees minus 40 degrees. 180 degrees minus 40 degrees is 140 degrees. So to that, we found out that sinus 40 degrees equals to sinus 140 degrees. Okay, and we have, again, from this equation, we have that sinus 40 degrees equals to sinus 140 degrees. Those two sides of the equation are equal to each other. But we already found out that sinus beta equals to sinus 40 degrees. So we can add to this equation that sinus beta also equals to sinus 140 degrees. Sinus beta equals to sinus 140 degrees. And from this equation, sinus beta equals to sinus 40 degrees equals to sinus 140 degrees, we will derive that sinus beta equals to sinus 140 degrees. If sinus beta equals to sinus 140 degrees, it means that beta equals to 140 degrees in its size. So according to the second solution for beta, beta equals to 140 degrees in its size. And the first solution for beta is beta equals to 40 degrees in its size. But if we look again, if we take a look again, this green triangle BCD, this is angle beta. From the drawing, it is very easy to see that angle beta is definitely greater than 90 degrees. If beta is greater than 90 degrees, beta can never be equal to 40 degrees, that is less than 90 degrees. So this is the first solution for beta, and we took into account on the second solution for beta, that is beta equals to 140 degrees in its size. This is the missing angle beta, is equals to 140 degrees in its size. So the green triangle BCD, 30 degrees plus 140 degrees is 170 degrees. So 170 degrees plus the size of this furnace again, so that must be equal to 180 degrees, according to the rule that says that the sum of the angles in a triangle is equal to 180 degrees. 30 degrees plus 180 degrees, 30 degrees plus 140 degrees, that's the size of the first missing angle BDC, to that DBC, to that must be equal to 180 degrees. 30 degrees plus 140 degrees is 170 degrees. So 170 degrees plus the size of the first missing angle, DBC in total must be equal to 180 degrees. If subtracted 170 degrees from this equation, and found out that the missing angle DBC equals to 180 degrees minus 170 degrees is 10 degrees. So this is the missing angle DBC equals to 10 degrees inside. Our task is to find out the size of this big angle ABC. The size of this big angle ABC equals to x is 50 degrees plus 10 degrees, that is 60 degrees. So if you found out that the size of the big angle ABC is equal to x is equal to 60 degrees. So finish to repeat on the first question. In the next step, repeat on the solution of the second question on both methods. In the second question, our task is to find out the length of side AD equals to x. We have to find out the value of x. So in the drawing we have quadrilateral ABCD. We know that AB equals to BP. Those two angles are both right angles. Side, the short line side DP is equals to 1 unit. Line segment PC equals to 4 units in itself. Again, our task is to find out the length of side AD is equals to x. We have to find out the value of x. Actually, we found the value of x by using two different methods. So, a bit on the first method. In the first step, we join points B and D together by straight line. By joining points B and D, we divided the quadrilateral ABCD into two right angles. So we calculated there are those two we implemented the law of cosines on both those two right angles. So first of all, we implemented the law of the Pythagoras theorem on this right triangle ABD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. So in this upper right triangle ABD, according to the Pythagoras theorem, BD squared, that is the square of the hypotenuse, equals to AB squared plus AD squared. Repeat again, this upper right triangle ABD, according to the Pythagoras theorem, BD squared, that is the square of the hypotenuse, equals to AB squared plus AD squared. BD is the missing side, so we leave it as it is. So it is BD squared equals to AB squared plus AD squared. AD is x, so AD squared is x squared. So total, if you found out that according to equation 1, BD squared equals to AB squared plus x squared. Likewise, implemented the Pythagoras theorem on this right lower triangle DBC. According to the Pythagoras theorem, in this right lower triangle DBC, DB squared, that is the square of the hypotenuse, equals to BC squared plus DC squared. And again, this lower triangle DBC, according to the Pythagoras theorem, DB squared equals to BC squared plus DC squared. DB, BC, we don't know the length of DB and BC, so we leave them as they are. But DC total equals to 4 plus 1, that is 5. Therefore, DC squared equals to 5 squared, that is 25. So in total, according to equation 2, we found out that BD squared equals to BC squared plus 25. Because of the fact that we have two different equations for BD squared, we get the equation 3 that says that BD squared according to equation 1 must be equal to BD squared according to equation 2. BD squared according to equation 1 equals to AB squared plus x squared must be equal to BD squared according to equation 2. BD squared according to equation 2 equals to BC squared plus 25. So total, if you found out that according to equation 3, AB squared plus x squared equals to BC squared plus 25. In the next step, we implemented the Pythagoras theorem on this green right triangle PBC. According to the Badat theorem, this red right triangle PBC, PB squared, that is the square of the hypotenuse, equals to BC squared plus CP squared. Again, red right triangle PBC, according to the Badat theorem, BP squared, that is the square of the hypotenuse, equals to BC squared plus PC squared. According to what is given as a question, AB equals to BP. So we can substitute AB by P. We can substitute BP by AB. So BP squared is AB squared, and it equals to BC squared plus PC squared. This is according to equation 4, but according to equation 3, we only found out that AB squared plus X squared equals to BC squared plus 25. So we can substitute AB squared in this equation 3 by BC squared plus PC squared from equation 4. We did it, and we found out that AB squared equals to BC squared plus PC squared plus X squared. And the other side of the equation 3, we have BC squared plus 25. We have BC squared on both sides of this equation, so BC squared will get cancelled, after cancel BC squared. And on this side of the equation 3, we're left only with PC squared plus X squared. PC is 4, therefore PC squared is 4 squared, that is 16. So we substitute PC squared by 16, and we have plus X squared equals to 25. So total according to equation 3, we found out that 16 plus X squared equals to 25. Here we subtract the 16 from this equation, and we found out that according to equation 3, X squared equals to 25 plus 16 is 9. So X squared equals to 9. Here we took out all those equations, and we found out that X equals to the square root of 9, that is 3. So 97 AD is equals to X, is equal to 3 instead, according to the first method. And the next step, I put on the solution of the second method. We find out the value for side AD according to the second method. I put on what we already done according to the second method. In the second method, we did the construction. That is to say, we extended side DC by 4 units. Again, we extended side DC of this quadrilateral ABCD by 4 units. And we find the edge of the extended line segment. This point is point Q. So CQ equals to 4 according to our construction. Again, CQ equals to 4 according to our construction. And DC is one side of quadrilateral ABCD, therefore it is absolutely a side line. When extended side line by side line, there is that DQ is also a side line. So if you focus on the upper side of the side line DQ at point C, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 said that the sum of the angles from one side of the side line is equal to 180 degrees. So which angles we have at the upper side of the side line DQ at point C? We have this angle that is the right angle, plus this missing angle, in total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle is equal to 90 degrees in its size. In the next step, we join points B and Q together by side line. By joining points B and Q, create the right triangle BCQ. So, in the next step, I shall prove that those two right triangles can go into each other according to side against side rule. So, why those two right triangles can go into each other? First of all, PC equals to CQ equals to 4. CQ equals to 4 according to our construction. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, BC is a common side that belongs to both triangles, so you can write down that BC equals to itself is a common side that belongs to both triangles. So if you prove that those two right triangles can go into each other according to side against side rule. And again, if you follow that triangle PBC can go, this is the same congruent to the right triangle BCQ according to side against side rule. This is to say, if you prove that those two sides, and the angle is included between those two sides in this triangle PBC corresponding equal to those two sides, and the angle is included between those two sides in this triangle BCQ. Therefore, if you prove that those two triangles can go into each other according to side angle side rule. That is to say, those two sides and the angle that is included between those two sides in this triangle PBC corresponding equal to those two sides, and the angle that is included between those two sides this triangle BCQ. And therefore, those two triangles can go into each other according to side against side rule. And from the fact that those two triangles can go into each other, we will derive that PB equals to BQ. Again, we will derive that PB equals to BQ. PB equals to BQ according to the rule that says that corresponding sides and congruent triangles are equal to each other. Those two right triangles can go into each other, and therefore their corresponding sides, that is to say PB and BQ, must be also equal to each other in their lengths. So PB equals to BQ. But according to what is going on in the question, AB equals to PB. Therefore, all those three sides are equal to each other in their lengths. So if you found out that AB equals to BP equals to BQ. In the next step, we did a construction, that is to say, we do a circle around point B in such a way that point B will be the center of the circle, and the radius of this circle is BA. Repeat again, we do a circle around point B in such a way that point B will be the center of the circle, and BA will be the radius of the circle. And because of the fact that BA equals to BP equals to BQ, and BA is the radius, therefore BP and BQ must be also the radius of this circle. Okay, repeat again. Actually, created here a circle with the center of point B and the radius of SBA. So BA equals to R, it is the radius of this circle according to our construction. So, according to what is given us in the question, DA is perpendicular to AB. But AB is the radius of the circle. So DA is perpendicular to AB and AB is the radius. That is to say, DA is perpendicular to the radius. DA is perpendicular to the radius of this circle is point A. Therefore, DA must be a tangent to this circle is point A. DA is the tangent to the circle is point A. We will focus on this common standpoint, point D. From the common standpoint, point D, we have tangent DA, that is tangent to this circle is point A. Likewise, from the same common standpoint, point D, we have secant DQ. So all the requirements of rule of tangent secant theorem are satisfied. Therefore, we can implement tangent secant theorem at this common standpoint, point D. And according to tangent secant theorem, from a common standpoint, point D, we draw tangent DA, and it's tangent to this guy is point A, and we have also from the second common standpoint, point D, we have secant DQ that cuts the second 2 points P and Q. Then the length of the tangent squared is, that is to say, dA squared equals to dP times dQ. Again, dA squared equals to dP times dQ. According to tangent secant theorem, dA squared equals to dP times dQ. So repeat on tangent secant theorem again. according to tangent secant theorem, if a tangent and the secant are drawn to a circle from the same convection point P, yeah, from this convection point P, we have tangent P8, it is tangent to the secant point A. Likewise, from the same convection point P, we have secant PC that cuts the circle at 2 points, B and C. Then the following equation is true. The square of the tangent's length equals to the product of the secant's all length and its external part. Essentially, tangent square equals to external secant part times all part. Or PA square equals to PB times PC. Okay. So it is this drawing, the following equation is true. According to the tangent secant theorem. The length of the tangent squared, that is to say PA square equals to PB times PC. Again, PA square equals to PB times PC. So, we implemented the tangent secant theorem on this convection point D. From the convection point D, we have tangent D8 that is tangent to the secant point A. Likewise, we have secant DQ that cuts the circle at 2 points P and Q. So all the requirements of tangent secant theorem are satisfied, and therefore we can implement the tangent secant theorem. According to tangent secant theorem, dA squared, that is the length of the tangent squared, equals to dP times dQ. And again, according to tangent secant theorem, if we focus on the convection point D, dA squared, that is the length of the tangent squared, equals to dP times dQ. dA equals to x, and therefore dA squared is x squared. And it equals to dP, dP is 1 times dQ. dQ in total is 1 plus 4 plus 4, that is 9. So in total, we shall all know that dA squared equals to dP times dQ, and it is actually x squared equals to 1 times 9, that is 9. So x squared equals to 9. If we to go to out of the equation, if I found out that x equals to the square root of 9, that is 3. So if we found out that this is line 7dA equals to x and x equals to 3. So if we found out that the length of line 7dA is equals to x is equal to 4 units on both methods. Okay, thank you very much.